Hello everyone and welcome. Today I'll present to you about Amazon DynamoDB and share some untold stories of databases in a serverless world. My name is Angela Timofte and I work as a data platform manager at Trustpilot. I've been with the company for almost 6 years, so I've accumulated a lot of database stories to share with you. If you'd like to stay connected and talk more about databases or serverless in general, please look me up on Twitter by using my name, Angela Timofte. But now, let's look at the agenda that I prepared for you today. So, we'll start with a few words about who is Trustpilot, then we'll jump right into the journey we had with databases and look more closely at DynamoDB, followed by the infrastructure we are running today, and then the most interesting part, looking at modeling some real-life data into DynamoDB. And this is very exciting because, when you try to learn something new and you Google for some tutorials, all you can find are those hello world type of examples. But then when you try to apply those learnings to your scenario, things get way more complicated. So that's why I want us to look at some real-life data and how we'll model that in DynamoDB, and I can share with you some gotchas and tricks that I learned the hard way. And in the end, I can't have any presentation without sharing some lessons that I learned, and hopefully you'll learn from our mistakes. And in case you've already have done some of these mistakes, at least you'll hear that you're not alone. But now let's get started. So, who is Trustpilot? I'm sure many of you have heard about Trustpilot and even used Trustpilot, but for those who haven't, Trustpilot is an online review platform whose mission is to help people have better experiences when purchasing online. And at the same time, we want to help businesses improve their offerings and connect with their customers. But to understand better some of the tech decisions that we had to make, I want to share with you some numbers. And here I put together a chart where you can see the number of reviews that we've collected over time. The company was founded in 2007, and if you look around that time, we were not really getting that many reviews. But since then, the company has grown substantially. And now we are happy to say that we have more than 100 million reviews collected. And we are very proud of this growth. And as a company, it's amazing to see this kind of growth. But this, of course, came with challenges when it came to the technical decisions that we've taken. And with that, I want us to start looking at the database transitions that we have made at Trustpilot. As I mentioned earlier, the company was founded in 2007. And at that time, we didn't really have any data. So the last concern we had was where the data is going to be stored. So for that reason, we just decided to put our data in a MySQL database on premise. But as the company started to grow, we started to have a lot of issues with this decision. Very early on, we noticed that we needed database experts to take care of versioning and updates and everything that you need for an on-premise database. And the biggest issue that we were having was scaling the database. And it actually got so bad that the database was putting down the website quite frequently. So that's why around 2011, the company has decided to move all of the data into MongoDB. And at that time, MongoDB was gaining in popularity, and being a document database was also perfect for the type of use cases that we had. And that's when we started transitioning all of our data from MySQL to MongoDB. But this project took us quite some time, and to be more precise, we finished this in 2017. But in that period, this was not the only project that we were working on. You see, the company was growing quite a lot, so we had to hire a lot of new people, which needed training. We're also refactoring our entire code base from a monolith to microservices. And of course, as any business, we're also developing new features. But In 2017, we were done with this transition. And in Trustpilot style, we had a celebration. And at this party, one of my colleagues came to congratulate me because I was actually part of the people that moved the last bits of data. But after he congratulated me, he continued with a question, which was, "So, Angela, now tell me, when are we going to be out of MongoDB?" And to be honest, for a second, I kind of wanted to kill my colleague, but I didn't. You see, even before we're done with transitioning our data to MongoDB, we've started to have issues with MongoDB itself. And in all fairness, some of the issues were because of mistakes that we've done. And for example, in the beginning, we were storing all of our data into one cluster. So that meant when we were putting too much pressure on one of the data points, the whole cluster will fail. So that was a mistake on our side. But in the same time, since 2011, when we took the decision to move into MongoDB, the company has grown even more, and the use cases also changed. So we knew we had to look for alternatives. So that's why in 2017, we started to look at DynamoDB. But one thing that we've learned from the previous transition was that you should never put all of your data into one type of database. And that's because nowadays we have the luxury to choose from multiple types of databases that have been created for different use cases. So you should always look for the one that is doing exactly what you have to do. And I'm happy to share with you the new infrastructure we are running today. And as you can see here, we are still using MongoDB because it's still the right choice for some of the use cases that we have. But then we have a multitude of other data stores like Redshift and RDS and Aurora and of course DynamoDB. And if you look at the numbers that I'm sharing here, you will see that DynamoDB is our most preferred type of data store. But of course, that wasn't the case when we started to look at DynamoDB. In reality, we didn't really have a smooth transition to DynamoDB because we're so used with MongoDB. We're so used the way we would store the data, the way we would query the data, the way that we would scale the database in MongoDB. So it wasn't that easy for us to adjust to the way DynamoDB is working. And now some of the things that we're not really considering and we had issues with was the fact that we're not looking at how we're provisioning our tables. And in the scenario I'm sharing here with you, you can see that we are provisioning a lot more than we are consuming. And in this case, we are actually ending up to pay more than we should. And that's not a good use case of a serverless database as DynamoDB. And actually, the way we ended up in this scenario was that at some point we're running some scripts and we changed the auto-scaling policy. And then, of course, we forgot to update the auto-scaling policy, and we ended up in this situation where we were scaling a lot more than we needed. Then another scenario where, again, we're not considering how our tables were provisioned, it's actually the opposite of the one I shared previously. And here you can see that we are consuming a lot more than it's provisioned. And in this case, you can end up with your data being throttled. And also, if you don't have mechanisms in place to retry, you can end up losing the data. So it's really not a good situation to be in. So definitely think about provisioning. But I'm here to tell you that you can avoid all of the issues that I presented previously if you just go and use on demand. And here I'm sharing with you a chart where you can see how nicely DynamoDB is scaling up and down based on the consumption. But actually at Trustpilot, we didn't switch to on-demand right away because we had this misconception that it will be more expensive. But after we've noticed so many cases like the ones I mentioned previously, we decided to run a test. And guess what? The opposite was the reality. And for that, since then, by default at Trustpilot, we are creating DynamoDB tables with on-demand scaling. And the other thing that I want to point out when looking at this chart, actually just because this chart makes me happy when I look at, imagine if you were using a traditional data store where you would have to provision for your spikes. Well, if you were to do that in this situation, you can see how you would pay for so much more than you had to. And honestly, that's the beauty with serverless databases like DynamoDB, where you can just pay for what you are consuming. But moving on, another misconception that we had was that DynamoDB, it's just a key value store. And you see, in the beginning, when we were thinking about DynamoDB, we were just thinking that we can only use it for like simple data where we just put a key and we get a value, and that's kind of it. And that's why we're never really thinking of how we're modeling our data. And here I'm sharing with you a table where you can see we're just dumping some data in there, and you see like one item is a list of 161 items which have even more properties. And the way that we're accessing this data was we're just giving the primary key as a review ID, and then taking that data and looking through the list and checking for something specific in that list, and based on that taking a decision and then go back to the database. So it was really not a great way of modeling the data and the way that we were accessing the data. And actually, this was our most expensive table at the time because we just didn't think about how we were going to access the data in there. So with this in mind, I want us to move to the next part, which is, as I promised in the beginning, the most exciting part. And that is how we model some real-life data in DynamoDB. And here I'm sharing with you a simplified use case. But if you go to trustpilot.com to our category page, you can see all the data there. And I actually challenge you to see how would you store all of that data in DynamoDB. But first, let's look at what I prepared here. So when talking about modeling data in DynamoDB, the first thing that you have to do is look at the queries that you want to make. And in our case here, the first query that I want us to make is to get a list of businesses for a specific category ID with a specific country and status, which can be claimed and unclaimed, and sorted by the number of reviews in descending order. Then the next query that I want us to make is to get a list of categories for a specific business. So this sounds quite difficult to do in a DynamoDB key value store, right? But let's see how we're going to do that. First of all, let's look at the data that we want to store. So for an object, we'll have a business unit ID, we'll have a list of ranked categories because a business can be in one or multiple categories. Then we'll have an identifying name, we'll have a review number, we'll have the status and the country. So now let's see how are we going to model all of this in DynamoDB. Well, as simple as this. But now let's look closer at what exactly are we doing here. So we have decided to use as a primary key the category list, then a sort key in which we are going to store the country, the status, the number of reviews, and the identifying name. And I'm here to tell you that the reason why we put the identifying name in there is to make the combination between primary key and sort key unique. And that's something that you have to consider when you save data in DynamoDB, that combination is unique. And then the third column is for the business ID. But now let's go back to those queries that we wanted to make. So the first one that we wanted to get results for was to get a list of businesses for a specific category, let's say clothes, in Denmark with the status claimed, and they should be ordered descending by the number of reviews. So to get that, the query that we're going to make is primary key equal clothes, and then sort key equal DK and claimed. And the results that we expect are these ones, where we get the right category, clothes, and we get DK claimed, and then company 1 as the first item because it has 1,500 reviews, and company 2 as the second because it has 250 reviews. But in reality, that's not what we are receiving. In reality, we actually get company 2 as the first item and company 1 as the second. And that's because, you see, we are using a sort key, which is a string. And in that string, we are trying to order numbers. So in our case here, number 1 from 1,500, it will be compared to number 2 from 250. And that's why we get this order. And we actually found a quick solution on how to store the data correctly to actually get the right ordering. But I have to tell, when we noticed this problem, we had for a second question our decision of putting data in DynamoDB. And that's why it's always important to really try and practice modeling data and see if you find situations like this. But now I'm here to show you what's the solution in this case. So for us, it was easy to fix this by just putting zeros in front of the numbers so the right digit is being compared. And we did that by taking the largest number of reviews that we had, and then we knew exactly how many zeros to put. And we are refreshing this data every day, so it was very easy for us to update this. But it's something that you have to consider if you are to do something like this. Then the next query that we had to make was to get a list of categories for a specific business. So in this case, we are going to use a global secondary index, and let's say we want to get the items that have business ID equal 1, 2, 3. And the results that we'll get are these ones. And this is correct, no gotcha here. This is what we expect. But when working with global secondary indexes, something that you always have to consider is taking advantage of projected attributes. And the reason you want to do that is because you want to make your index as small as possible so that you pay less, of course. And in our case here, if we were to do that, the results that we'll get are these ones, where we just get the list of categories and the business ID. And of course, the example that I'm sharing with you here, it's quite small, but imagine if you had like a huge table with a lot of data in it, and then you were to project all the attributes and pay double for that data, even though you don't need it. So really think about this when you use secondary indexes. And with that, let's look at some lessons that I want to share with you. So the first thing that you need to consider when you want to start using DynamoDB is that it's a shift in mentality. And if you want your team to start using DynamoDB, really give them time to adjust to the way the DynamoDB works. Because we've noticed in our case, we're so used with MongoDB that it took us some time to see those access patterns and how we can store data in this new way. And I'm actually still noticing that when I get new employees, or when I give some of the more complex databases that we have to other teams that don't have experience with DynamoDB, it takes them some time to see these patterns. So really give people time to adjust to this. And the next lesson, like anything in life, it requires practice. You really need to practice with DynamoDB so that you get to see these possibilities and these ways of storing your data in DynamoDB, because it might not be so obvious in the beginning. Then the third lesson that I want to share is that you should probably verify your scaling policies and consider on demand. And for us was the right choice to move to on demand, because we noticed our memory was not so great, so it was better to leave Amazon to do this for us. But even if you don't want to use on demand, I still recommend you to go and check your auto scaling policies, and you might find out some things that you forgot, like we did. Then the next lesson, I think this one is the most important, is that you should model your data based on the queries that you are going to make. And I can't stress this enough, because you see, if you don't save the data based on the queries that you're going to make, you end up scanning your data. And you don't want to scan your data, because then you end up looking through the whole database before you get the result you want. So really think about the queries that you want to make and then model your data. And with that, the last lesson that I want to share with you is that if it's expensive, it might be an indication that you're doing something wrong. And actually, I'm kind of always going through the tables that we have and look at the most expensive ones, and almost all the time I find something that we're doing wrong in terms of like how we access the data, or like the global secondary indexes that we have, and so on. So I really encourage you to go and check your expensive tables and share with me if you find something wrong with them. And with that, I want to say a huge thank you for listening to my presentation. I really hope you learned something. And please, if you want to stay connected and talk more about databases, serverless, or anything for that matter, look me up on Twitter by using my name, Angela Timofte. Thank you, and bye-bye.